Hey guys, welcome back. Today we're going to learn about linked lists. You probably won't use a linked list much in practice, but it does come up in coding interviews now and then, so it is good to know. Let's start with a definition of what a linked list is. A linked list is made up of nodes, and each node points to the next node in the list. Typically with linked list problems, you'll need to keep track of the head, which is the first node, and the tail, which is the last node. This is so that insertion on either end of the linked list can happen in constant time. Let's go ahead and build a linked list class and see how this works. Let's start by defining our node class. We'll initialize it with some kind of data and a pointer to the next node. Now we could stop here and just declare some nodes and set their next pointers to other nodes, and that would technically be a linked list. However, as I mentioned before, we generally want to keep track of the head and tail nodes, so let's create a linked list that will keep track of that data for us. So at first, the linked list is empty, so we can initialize the head and the tail to none. In order to add nodes to the linked list, let's write an append function that will add a new item to the end of the linked list. Let's start by creating our new node. And we know that if we're adding something to the end of the list, that we're going to be replacing the value of the tail. So let's check if the tail exists. If the tail exists, then we want to set the existing tail's next pointer to our new node. Now we can go ahead and set the tail to our new node. The last thing we need to do is consider an edge case where the linked list is empty and our new node is now the first and the last item in the list. So if that's the case, we need to go ahead and set the head to the new node. Okay, I think that should do it. Let's create our linked list and see if it works. And we'll try appending a few values. So we would expect that the head is 1 and the tail is 3. And that's what we get. So it looks like this is working. So the last thing that I want to talk about is the time complexity of a linked list. If you're inserting or deleting elements on either end of the linked list, so at the tail or at the head, then it happens in constant time. And that's because we can go straight to that element and delete it or add a new item. However, searching through the linked list is a lot less performant. And that's because you have to go through each item in the list in order to find what you're looking for. So that about covers it for linked lists. If you liked this video, please feel free to give it a thumbs up and subscribe if you want to see more content like this. And if you have any questions, definitely leave a comment. And thank you so much for watching. I'll see you next time.